The topic that I'm going to take today is dual converters. What do you mean by term dual? Dual means two. Two means when two converters are taken, when two converters are connected together, it forms a dual converter. Now, what is the need of dual converter? How do we achieve it? And how do we operate a dual converter? To take to understand this, let us first recall what a full converter is. A full converter is supposed to give you the DC output. Now, the DC output that we get through a full converter for an RO load is 2 Vm by pi cos alpha. Try to recall that formula, 2 Vm by pi cos alpha. Now, if the value of alpha is kept from 0 to 90 degree, we get the output voltage as positive, while if we keep the value of alpha from 90 to 180 degree, we get the output voltage as negative. So that means the output voltage for a full converter can be positive, it can be negative based on the value of alpha at which the thyristors are fired. Now for both the time, for whatever is the value of alpha, the current will be unidirectional. Why? Because the switches, which are SCR in this case, the switches used are unidirectional. So if the switches are unidirectional, the current is going to be same. So that means for any full converter, we can get the operation over two quadrants. One is in the first quadrant and the second is the fourth quadrant. That means either we can get operation here or here. So if we wish to get the operation in the other two quadrants as well, or if we wish to have the four quadrant operation, then we use two full converters. Or in simple words, if we wish to get the direction of current at the load reversed, then we may have to use one more converter which will give you the reverse current as well. So if we connect two converters in anti-parallel and if we keep the load as same, we get a dual converter. So a dual converter is something which gives you a converter, which gives you a combination of two converters, and that combination is able to provide you the operation of converter in all the four operations or the four quadrants. Now let us see how do we achieve it. Now this is a dual converter which is for single phase, and this is another dual converter which is for three phase. Now for a single phase, let's try to, because the working of these two is same, so let us try to understand with the help of a single phase dual converter. In this dual converter, let us say I need a voltage of V naught at the output with this terminal as positive and this terminal as negative, and let us say I need the current in this direction. So if I need the current in this direction and the voltage is positive and negative, then what we could do is we can take out the converter at the right side and we can take in the converter at the left side. So we will operate the converter which is at the left side. We will not operate this converter. So when this is operated, when this is operated for alpha less than 90 degree, the output voltage will be positive here and the current will be flowing from top to down, and we will get the operation in quadrant 1. Now if we increase the value of alpha more than 90 degree for this converter, then the load voltage will reverse. It will become negative here and positive here, while the direction of current will remain same, that is from top to bottom. So during this time we will get the operation in this quadrant. Now by operating the converter 1, that is the converter at the left side, by operating the converter 1, we can get the operation in these two quadrants. Now if we wish to reverse the direction of current, or if we wish to have the operation in these two quadrants, then what we'll do is we will take out this converter from operation and we'll bring this converter into operation. So at this time, for these two quadrants, quadrant 2 and quadrant 3, this will not be operated and this converter will be operated. So when this converter is operated and alpha is kept less than 90 degree, this terminal will be positive and this terminal will be negative, and the current will flow from bottom to top. During this time, when this is operated, the current will move from bottom to top. So for alpha less than 9, more than 90 degree, if you wish this voltage as positive, you need to keep alpha more than 90 degree. If you want this voltage as positive, you will keep the alpha less than 90 degree. So for alpha less than 90 degree, we'll get the operation in this quadrant. For alpha greater than 90 degree, we will get the operation in this quadrant. So for these two quadrants, converter 2 will be operated. For these two quadrants, converter 1 will be operated. That is how we go for it. I have used the term non-circulating. Let's try to understand what is this. But before that, let me finish this slide. This same operation will be done for the three-phase converter. This will be operated for these two quadrants, and this will be operated for these two quadrants. Now let's try to see how we do it. How we do it. For getting the operation of these two converters, let us take the example of ideal dual converter. Ideal dual converter means we have considered two converters. One is converter 1 at the left side, another is converter 2 at the right side. Let us say we need to have the voltage output as positive here and negative here. And let us say fired at both of the converters are fired, because at one time there can be two modes of working of a converter. One is a non-circulating current mode, another is a circulating current mode. So for non-circulating current mode, what we do is at a time we operate either converter 1 or converter 2. So at a time only one converter is operated. But for the circulating current mode, we may operate both the converters at the same time. Now, what is the benefit of using it or doing it? We'll try to discuss more on this. So, as if we assume the dual converter as an ideal converter means we have assumed that the output voltage is constant over the period for which it is working. That means this is positive and this is negative. Now, how to get this? How is it possible that both the converters gives positive voltage at the output? Because they are connected to the same supply. If they are connected to the same supply and we need the output voltage as this positive and negative all the time, that means the firing angle for these two should be such that if the firing angle of this converter is less than 90 degree, the firing angle of this should be more than 90 degree. So at one time we keep its firing angle less than 90 degree, its firing angle more than 90 degree. Then only we can get this voltage as positive and negative. Now let's see what happens for the duration of firing angle. Alpha 1 is the firing angle for this converter and alpha 2 is the firing angle for converter 2. Let us say alpha 1, converter 1. Converter 1 is operated at 0 degree. So if converter 1 is operated at 0 degree, that means its voltage is V0 1. So by increasing the alpha, its voltage will go on decreasing up till 90. At 90, the voltage of converter 1 will be 0, and after 90, this voltage will start becoming negative. Similar way for alpha 2, when alpha 2 is changed from 180 degree to 0 degree, the voltage goes like the one shown here. Now, this how this is possible? We want this load voltage to be positive. If we wish this load voltage to be positive and we wish to conduct both the converters at the same time, then we may have to apply a trick. Now, what is that trick? This can only happen if one converter is operating as a rectifier and the other converter is operating as inverter. Now, if one will operate as rectifier, this will operate as inverter. If this operates as rectifier, this will operate as inverter. So the operation of these two will be opposite. Then only the voltage will be positive. You can see this V02 is giving a positive voltage from 90 to 0 degree, while V01 is giving a positive voltage from 0 to 90 degree. So for this, it's 0 to 90 is basically 90 to 180. So here, let us try to find out through this. V01 is V0M cos alpha 1. This V0M is 2Vm by pi. This V0M is 2Vm by pi. So for a single phase full converter, VOM is 2Vm by pi, whereas for a three-phase full converter, this VOM is 3VML by pi. So 2VML by pi cos alpha will be the output of converter 1. Similar way for the converter 2, the output will be 2VML by pi cos alpha 2. Now these two voltages under normal operation, output voltage of converter 1 has upper positive and lower negative polarity, and output voltage V02 upper has negative and lower has positive. Why? Because in normal condition, this converter is going to give you a positive here, and this converter is going to give you a positive here. This is under the normal condition on which this is based. Now, their output voltages would have the same polarity only if polarity of V02 is reversed. What does it mean? If this is operated, it is going to give a positive for alpha 0 to 90 degree. This is going to give you a positive here. And for this 0 to 90 degree, it is going to give you a positive here. That means it will be positive. It will be positive here. Now, if both the converters are fired from 0 to 90 degree, this will be positive, and from here this will be positive. But what we want the voltage to be positive for both. So if this is positive and we also want this as positive, that means we need to keep its alpha as more than 90 degree. This is what we are doing here. So we are reversing the voltage of V02. So if voltage of V02 is reversed, that means V0 is equal to V01, that is equal to minus V02. So if we substitute the value of V01, which we wrote here, so equation 1 and 2, if we substitute these equations here, we get V0M cos alpha 1 is equal to this, or cos alpha 1 is equal to minus cos alpha 2, or this, or we get alpha 1 plus alpha 2 equals to 180 degree. We can, if we solve it, we can get this as the one solution. We can also get this solution, but this solution is not possible, because for any thyristor the firing angle cannot be more than 180 degree, and alpha 2, if it gets added to 180 degree, it will be more than 180 degree. So this goes invalid. So that means this solution goes invalid. This is the only solution which is going to be valid. So alpha 1 plus alpha 2 is equal to 180 degree. This is the only solution which gives you the operation of this dual converter if 1 and 2 are operated simultaneously. So we discussed two cases. In one case, we discussed that one converter is operated at a time, other is kept idle. In another case, we discussed that both are operated at the same time, and when both are operated at the same time, its firing will be done from 0 to 90, its firing will be done from 90 to 180, or you can say the firing of both the converters will be done such that alpha 1 plus alpha 2 is equal to 180 degree. That means if alpha 1 is kept as 60 degree alpha 2 will be done, will be kept as 120 degrees. Now here if alpha 1 is kept as 90 degree, alpha 2 will be kept as 90 degree. If alpha 1 is kept as say 120 degree, alpha 2 will be kept as 60 degree. So depending upon the kind of voltage you want here, the firing angle of these two will be calculated. But yes, the firing angles alpha 1 plus alpha 2 should make 180 degree. So based on all these discussions, we can have the dual converters working under two modes. The very first mode is called the non-circulating current mode. The one which we discussed that at one time one converter will be conducting, and at the same time the other will be kept idle. This case is called non-circulating current mode. Non-circulating current mode, what is circulating current? We need to understand what happens actually. Here we discuss the case of an ideal dual converter. In ideal dual converter, we considered that the average voltage of these two converter is same. The average voltage of these two converter is same means if this is 60 degree, so it is going to give you a positive voltage, and if this is 120 degree, if it is going to give you a negative voltage which is with respect to load is positive. So the voltage given by this and voltage given by this, the average voltage of both will be same. But this is what we considered. The average V01 is equal to V02. This is what we discussed in case of ideal dual converter. But practically, this doesn't happen because the waveforms are different for both the converters. So one converter will have some instantaneous voltage and the other converter will have some other instantaneous voltage, because of which there is a voltage difference that gets created in these two converters. So these two converters, I repeat, these two converters practically will have the same average value, but the instantaneous voltages of these two converters will not be same. So at any time this voltage may be less than this voltage. So if this voltage is greater than this voltage, there will be a flow of current from this converter to this converter. And if this voltage is greater than this voltage, there will be a flow of current from this converter to this converter. So that means if these two voltages V01 and V02 are not exactly same, there will be a circulating current which is produced between these two converters. This circulating current, it may be avoided if one converter is operated at one time. So if one converter is operated at one time, it becomes non-circulating current mode. In non-circulating current mode, what we do? We operate this converter and we remove the pulses from here. When this is operated, now suppose we want to reverse the current, we will first remove the pulses from here, then we'll give a break of 10 to 20 milliseconds so that all these thyristors, they gets commutated properly, and then we shift the current to this converter. That means then we fire these thyristors. So if at a time one converter is operating, the operation is called non-circulating current mode. So let me read through. Only one converter is in operation at a time and the other is blocked from conduction. Suppose converter 1 is in operation and supplying the load. For blocking converter 1 and switching on converter 2, first the firing pulses from converter 1 are immediately removed. So when we wish to fire converter 2, we'll remove the pulses from converter 1. And during this changeover, we need to ensure that the load current is decayed to zero. And to ensure this, we introduce a delay of 10 to 20 milliseconds so that the current goes down to zero at the load and then the other converter is switched. So in this mode is one of the easiest mode. There will not be any circulating current, but the only disadvantage of this mode is when we have to change the converter operation from one quadrant to another quadrant, we need to introduce this time lag. So this slows down the process. This slows down the process. While if we keep these two converters working simultaneously, then the changeover will happen quickly. So this quick changeover is only possible if we are working these two converters simultaneously. Simultaneously means if this is fired at alpha 1, this will be fired at alpha 2, and the firing should be such that alpha 1 plus alpha 2 is equal to 180-degree. But in this case, because of the difference in the instantaneous voltages, there will be a circulating current flowing between these two converters, and this circulating current can be regularized, it can be minimized, or it can be balanced with the help of these reactors. So these two reactors are connected at the end of each converter, and the value of these two reactors is kept as same. So whenever the voltage difference occurs, these reactors comes into play, and they try to kind of, if it is laying the current, it is allowing the current, so they manage and balance the current, and the circulating current between these two converters is avoided. So this reactor becomes an important thing. So that is the reason in this in these two figures I have written the dual converters as non-circulating. Non-circulating because I have not used any reactor here. So these reactors which I have placed in this second mode, these reactors are placed so that the circulating current is not flowing. So this circulating current, I repeat, this circulating current is avoided by these reactors because these reactors balance out the voltage drops which are happening across the reactors, and they try to kind of balance the voltages so that the voltage remains constant at the load. So these reactors are used. The firing pulses are adjusted such that alpha 1 plus alpha 2 is equal to 180-degree. Now here this delay period is not required. Suppose this thyristor is this converter is giving a positive voltage here, and the current is flowing from top to bottom, and let us say the firing is kept as 60 and this is as 120. Now if you wish to reverse the current, if you wish that this firing is done from 60 to 120 and this firing is moved from 120 to 60 degrees, so this can be done immediately. The current in this case can be reversed immediately. This delay period is not necessary because we have already included the reactors in it, and both the converters are connected to the firing circuit. So both can be the firing, these two converters can be changed immediately. So the changeover from one quadrant to any other quadrant is easily possible in the circulating current mode. These are the waves pertaining to waveforms pertaining to this circulating current mode. This is the output voltage VCB, VAB, VAC. This is actually the voltage which is given. This is the voltage Vs that is applied to the input side. Now, when let us say these two are fired simultaneously, the switching sequence is to be kept something like alpha 1 and alpha 2. They should be equal to 180-degree. So that means if the alpha for V01 is kept as 120-degree, the alpha for this will be taken as 60-degree. So one voltage will be this and another voltage will be this. So if we add these two voltages, the load voltage will be this. this load voltage is almost constant, and it is only possible because of the presence of the reactor. This is the reactor voltage which keeps on regulating this load voltage, and this is the current, circulating current, which flows. It cannot be made zero, but yes, it can be minimized with the help of reactors, and the load current is more or less remains constant. This is the current through converter 1, this is the current through converter 2. Well, in this mode, what is the disadvantage? The very first disadvantage is a reactor is needed. This reactor is needed to limit the circulating current. The size and cost of this reactor may be quite significant at high power levels, and reactor introduces noise as well. So reactors are costly, and their size also increases with the power levels. Second is circulating current. If circulating current is developed in between the two converters, that means there is one current which is just circulating and it is not contributing to the output. So if this circulating current keeps on circulating without giving any output, so that means somewhere this current is creating losses. So this circulating current creates losses which lowers the efficiency and the power factor. Now again, since the current is flowing between the two converters, the current is flowing between the two converters, that and the current will be flowing through the power switches. So the power switches has to now handle the two currents. One is the current which is available for the load, and another current which is the circulating current. So the switches are handling two currents, the load current and the circulating current. So this puts a restriction, or this puts a condition to use the thyristors of the higher ratings. So we need to use the thyristors for the higher rating because they have to carry more current than the desired load current. So these three are the drawbacks, but yes, it has an advantage, that is the load current can be quickly reversed in this circulating current mode. So if you wish to immediately convert the current, or to bring the converter operation say from quadrant 1 to quadrant 4, it could be done immediately with the circulating current mode. So to conclude, I would say a dual converter is a combination of two full converters in anti-parallel. They are connected to the same load, same supply. The firing is done such that alpha 1 plus alpha 2 is equal to 180-degree. There can be two modes of operation. One is non-circulating current mode. In non-circulating current mode, only one converter is conducted, is operated at one time, while the another converter is kept idle. And the another mode is circulating current mode. In this mode, both the converters are operated simultaneously, and the firing scheme is kept such that alpha 1 plus alpha 2 equals to 180-degree. And here in this case, to limit the circulating current, we introduce, we use the reactors. By the use of reactors, the efficiency is reduced, the power factor is reduced, the cost is increased, and this circulating currents makes the rating of thyristors to be on the higher side. But yes, with the help of this circulating current mode, we can quickly change the quadrant operation of the converter. Well, this is all about the dual converters. The reference book is taken as Power Electronics by P.S. Bhimra. Thank you.